Hello and welcome to the presentation of the Master Program, Integrated Product Design at TU Delft. My name is Gerd. I'm a professor at the Industrial Design Engineering faculty in Delft, and I am the IPD Program Director. In the next minutes, I want to give you an overview of the Integrated Product Design Master Program and hopefully help you understand if this is the right master program for you. Let me start out by describing roughly what we're trying to do with the IPD program. As you might know, there are 3 different master programs at Delft. One more focused on the human aspects, the DFI master program, and the SPD Master Program more focused on organizational and innovation aspect. The Integrated Product Design Master Program is focusing more on the product, the technology, and the engineering aspects. The goal is really to teach design students, potentially you, how to design and engineer a viable and feasible, innovative product. And I have here 3 examples in front of me. On the left side, you see a design sketch, a concept of a future bicycle that is foldable, that can be easily put onto a bus, that also generates energy and has an electric motor. So it combines many different constraints. It makes use of new materials. In the middle, you see an example of a garment, a piece of textile, a wearable computer device to some extent, where light panels are integrated into the material to give an indication of the level of activity. So this is used for sports. And on the right side, you see an innovative packaging station, self-service packaging station for medicine. So these are examples, these are new products or services which you would like to design and develop by focusing on the integration of people aspect, technology, design, engineering, and sustainability. And if you look at the bottom of the screen, we are very much focusing on the end-to-end journey from vision to marketization of a product, but perhaps more focusing on the middle part from concept over design to development. And development is where the engineering aspects are very important, where it is around looking at material aspects, technological aspects, and to design a product that is not just desirable, but also feasible. In this master program, we focus on 3 particular aspects, namely future design materials, future product qualities, and future design methods. What does that mean? Here, future design materials. Now, 20 years ago, plastic, metal, wood and metal were the defining materials from which to build products. Now, increasingly, we have a much, much larger range of different materials. We have biomaterials, we have digital materials, data, algorithms, shape memory materials, conductive inks, printed electronics, smart textile. So a whole range of materials. And one goal of this master program is to help you understand how you can use all these different materials, combine them in innovative ways to use them as the building blocks for an innovative product. The second aspect is future product qualities. Now, what kind of qualities should the products which you should be able to design have? Now, they should be durable, they should be sustainable, they should be desirable, but increasingly we have a whole range of new product qualities which we can instill. They can be adaptive. they can be proactive, they can be responsive to users using sensors and digital technologies to understand how users behave. They can be learning, self-learning, using machine learning aspects. They can be shape-shifting, they can be luminous, lighting up. They should be sustainable, which means recyclable, relating to the circular economy or regenerative. So a whole range of different product qualities which we are aiming for. And all these different qualities might be more or less important depending on what kind of products you're aiming for. But the idea is to help you understand how you can use the different materials which are just introduced to create new product qualities which users and businesses can use to create value. And what do you need? And that's the third aspect. We need new design engineering methods. And so we're trying to teach you a range of different methods, from 3D printing, additive manufacturing, to robotic fabrication, computational design, 3D scanning, digital twins, and using a host of other computational methods like using machine learning, generative design, and so on, to use these methods to create new designs, innovative designs that have these new qualities using the materials which I just talked about. Well, this is quite theoretic. Let me just give you an example of what this might be. Here is an example of a recent graduation project from 2018. You see the design of a minibus. It's an autonomous ride-sharing vehicle, and it makes use of luminescent materials. So the whole body shell of this bus becomes a display. Using new technology, we don't have to confine displays to small rectangular areas, but we can use the whole body of a product like this as a display. And then the question is, what kind of information should a display, in which way is it visible from a distance, and so on. And so this very much relates to the new kind of materials which we have available. Here's another example of a graduation project from 2017. You don't actually see the product because it is being thrown away. It's a discus which has sensors in it that automatically measures the distance it is thrown. And in particular for indoors, using a fake discus that measures how far a real discus would be thrown. So it is part of the sports activity. It uses Internet of Things technologies. It uses sensors and digital technologies to improve performance in sports. And many different materials come together, from the physical materials to the digital materials, data, machine learning algorithms, and so on. And finally, the last example, a graduation project actually from 2016. This is a mycelium-based graduation project. It's using mycelium, a mushroom type of material, a living material, to build, in this case, a new packaging material, but it can be shaped in a variety of forms, and it can be used in a variety of contexts. And this project was exploring the use of mycelium in product design. I hope this gave you an indication of what we are trying to do, the different technologies, the different materials, design methods. Here is an outline of how the master program is organized. It's a 2-year program, 4 semesters. And in the first semester, we see a number of, in light blue indicated courses, IDE Academy, which is a selection of workshops based on specific skills. There is a Manage Your Master course that helps you understand of how to act, what to do to be successful as a master student. There's a course on design theory and methodology, but the biggest part is taken up by the advanced concept design. And there is a advanced embodiment design in the second semester. These are 2 big design courses that we are running together with companies to inject real-world case studies into the program, so that you not only learn theoretical topics, but actually can learn the theory and the technology and the new material aspects and the new design methods in the context of long-running realistic design projects. And if we look at the first year and we look at our roadmap from vision to market and concept development, design, and the product development, you see that the advanced concept design, a big first semester design course, is roughly aligned with the concept stage of product design. And the embodiment design is roughly aligned with the design to development stage. So in the advanced concept design course, we focus on developing innovative, desirable, feasible concepts. And in the advanced embodiment design, we are focusing on the practical realization and testing and evaluation of real product prototypes from different materials. And this is the example which I showed at the beginning. This is indeed an example from a company, Boston Group, one of our client companies, which injected a particular design case into the advanced concept design course. And a group of students tackled this design case and came up with a new concept, a concept for a innovative packaging station for ordering, saving, storing, and retrieval of medication. Now, this is a concept design, so it is fleshed out in CAD drawings, video prototypes, stories, descriptions, specifications, and the like. In the advanced embodiment design, we're doing the real thing. We're building the real product. Here is another example. It's a knee implant. It's for detecting periprosthetic joint infection. So after you had a new implant in your knee, you might develop joint infections in your knee. It's very difficult to detect this. So this implant has the ability to detect it automatically and help the doctors and the hospital to understand what is going on. This is a real-world case study that was injected. The design brief was injected into the advanced embodiment design, and a group of students took this on and developed the product to some level of fidelity, at least in a testable form, so that it could be developed further. Now, these were outlines of roughly the 2 big courses which we have in the first year. There are a number, as I indicated, there are a number of smaller courses around these big design courses. But looking at the second year, at semester 3, you then have the ability to pick and choose from a large selection of electives. And these electives are offered either within our faculty, or you can choose electives from across the university, or you can go abroad, take some courses at other universities, or indeed, you can do an internship. If you take one of our own electives within the design engineering, industrial design engineering faculty, you can pick electives focused on a range of topics, which are indicated here from different departments. Again, focusing more on the human aspects, consumer behavior, user experience, usability, to sustainability in the middle, biomanufacturing, circular economy, sustainable consumer behaviors, sustainable consumption, to the more technological and engineering aspects, 3D printing, scanning, advanced manufacturing, to smart material, robotics, Internet of Things, artificial intelligence. So there are a host of different electives. You can choose, pick and choose, or indeed do an internship with a company. And then in the last semester, you do your graduation project. One full semester, you work exclusively on one project together with at least 2 mentors from our faculty. Many of our students choose to bring in external companies, or we as mentors and supervisors provide company context, but there are also opportunities for doing more theoretical projects and more research-based graduation project. So this is a project that gives you just an example also of the complexity of the problems which our students tackling. So this is about designing a positioning system for minimally invasive surgery. So it is a concrete healthcare scenario. There was a hospital involved, there was a team of doctors involved, and the particular design problem here was to position the instruments at exactly the right location for this kind of surgery. Now, this is a very ambitious project, and we don't, of course, expect students to implement these kind of products and services in all its detail, but the idea is that every grad student has the opportunity to develop a functional prototype of a meaningful, interesting new product and service, or aspects of it, and has the ability to test and validate the design. And this happens very often together with some external companies. Well, where do IPD alumni work? When they end up, where do they end up? You see here the comparison between DFI, IPD, and SPD, master students with the integrated product design students in the middle. Most often, they actually become product designers. They might also end up as user researcher, consultants, or entrepreneurs. All right, that was it. If you have questions about the IPD program, get in touch. The contact details are here. If you have questions about admissions, get in touch with the counselors in our faculty or with general admissions. If you have particular questions about the IPD Master program, you can contact me at my email address as indicated here. All right, I hope you found this presentation useful, and I'm happy to answer your questions. Please get in touch. All right, thank you.